So hi everyone, happy Wednesday. We are here with Rob from Cycloid, Matt from Flagsmith. I'm Anna. This is our webinar talking about platform engineering and modern feature management in banks. This is something that sprung off of a joint ebook that we worked on together, looking at basically all the things that banks can do to modernize and change the way that they're releasing and developing software. So today we have experts from Flagsmith and Cycloid that can speak to each parts of their equation. So I won't spend too much time hogging the airspace, so I'll jump right in. So these are the speakers that we have here. This is a bit of an agenda of the things that we're going to talk to you today. So Rob and Matt, I'll let you introduce yourselves. Rob, do you want to go first?
Yeah, hi, thanks, Anna. Yeah, so Rob Gillam, I trained initially as an engineer. I worked for RSA Security as a support engineer and then a manager in the support team, primarily on cybersecurity for quite a few years. Then I sort of changed gear a little bit, went to work for Rackspace at the time when dedicated hosting was the latest thing, and I sort of stayed there quite through the transition into cloud hosting. So it's quite an interesting time to see how things developed. I then moved on to Ubuntu, where I was involved very much in promoting some of the private cloud initiatives around OpenStack. And now I'm here at Cycloid. My role is really to help people adopt platform engineering and DevOps processes. So great to be here. Thanks for inviting me, Anna.
Nice, yeah. Glad you could join. Matt, you're up.
Cool. Yeah, thanks, Anna. Yeah, so I'm Matt. I'm the CTO at Flagsmith. Been here working since its inception. I'm one of the co-founders. We spun Flagsmith out of an agency where I was working in London. So I've been working with the people who I work alongside on a day-to-day basis at Flagsmith for about 10 or 11 years now. Yeah, so exciting. It's really exciting times at the moment in the feature flagging space. We're definitely seeing a lot more appetite for using feature flags. So it's a really exciting time to be in the industry. So yeah, that's a bit of me.
Perfect. And that kind of, yeah, leads in nicely to why we're here, which is there's a lot of things, like a lot of changes happening in banking and software and feature flagging. And yeah, the idea is to talk a bit about platform and infrastructure, then feature flagging, and then tie it all together at the end. So let's jump right in. Rob.
Great, thank you. So I thought I'd start by just talking a little bit about platform engineering, what it is and what it isn't, before we talk about how Cycloid addresses some of these challenges. So I think it's important to start with users and what we're trying to achieve here, which is streamline workflows and basically automate tasks. But the sort of important thing is, who are the users? Platform engineering is discussed primarily with regards to developers. And yes, it does support a lot of the development activities, but that's not its only role. It also supports other types of users. For instance, you might have somebody doing, running some sort of digital agency or digital application, which they require to be provisioned for them, and that will be the function of the platform team. Even though they're not a developer, they still need access to these digital tools, and they will be provided by typically now by the platform engineering team. So it's a bit broader than just supporting the developers. And one of the things we strive to do is to be consistent and standardize environments, and that ensures not only just consistency, but also, we'll talk about later, security. We try to eliminate as much of the human errors as possible by standardizing, templating, building golden paths, and allowing the platform team to give things which are consistent across the whole organization. Reusability is absolutely part of it. You see, there are a lot of great work that goes on in silos, people building really cool tools and automation, but there's no way for those tools to be accessible to other people in the organization. So we have this term of federating, being able to federate the tools and the components that are built, but also applying some standardization and having them in a centralized place. And this kind of bridges some of the disciplines, certainly development and operations. DevOps practices have always promoted the interoperability of different functions. And I think platform engineering takes it that one step further. And what underpins it all is the focus on automation and self-service. The idea is to try and remove as much of the manual processes as possible, and at the same time, empower your users. And that obviously comes with challenges around, putting guardrails in place so as users can certainly, for instance, provision infrastructure, but only certain infrastructure at a certain cost, or with certain guidelines around what ports are open, for instance. All these guidelines can be put in place, and they create the ability to empower users to work and be more autonomous. Just a bit about what it's not. It's not just about infrastructure. Certainly, infrastructure is a big part of platform engineering, but it's also about providing access to tools and broader processes. And it's certainly not a replacement for DevOps. DevOps is typically a customer and certainly a part of the platform engineering process, but it's certainly not a replacement. The other piece is it doesn't fit all. It's not a one size fits all. We have customers that are just a few people to large enterprises. One of the beauties of platform engineering is you can adopt it in a modular fashion. You can take a business team, a business unit, and they can adopt it for their processes, and then you can roll it out in a modular fashion. So it is tailorable for different sizes of teams. And finally, the whole silo problem, we've seen this, people developing in isolation. It really does encourage collaboration. It's as much about delivering out services as it is about gathering the great work that teams have done around your organization and centralizing them in a way that other teams can benefit from it. We move next slide. So how does this sort of fit in with the banking industry? And I think there are some distinct challenges which we can address with platform engineering. One of the biggest challenges is really the way that the ops are traditionally organized. Typically, we see a ticketing system, somebody raises a ticket, then goes through some sort of workflow process, typically manual. It'll, for instance, a firewall change, it'll go to an ops operative who will make that change, close the ticket, maybe there'll be some sort of authorization process to make sure that port should be opened. And then it gets serviced and the requester can then get on with their job. But obviously there's time involved in that. And it's a pretty repetitive task. So this ops guy or person is going to basically be doing the same thing over and over again. We can certainly work a little bit smarter that and put some automation in there to allow people to self-serve those types of activities. And because a lot of activities are being done by humans, there's the opportunity to bring error into it. Everybody makes mistakes. We're all human after all. Trying to eliminate those by standardization and by automation and by having repeatable processes is one way to try and eliminate some of those human errors which tend to creep in. There's also the centralization aspect of it. A lot of what we see is organizations doing great work, but doing great work in isolation, because there is nowhere for that, for all those great bits of tooling and automation to live within a large organization. So being able to bring those into some central repository, then have them managed, and then have them standardized and make them available, federate them out to the organization is something that can definitely be achieved with platform engineering. And then there's the demands. All organizations, banking organizations in particular, being asked to provide more and more services. Customers really want the latest and greatest, and they want it today. This puts huge challenges on banking IT organizations to be able to respond in time. Having the tooling, having the ability to scale the tooling very very quickly is a real advantage that platform engineering can bring. Move on to the next one. And then this sort of leads us into this kind of infrastructure discussion. Where are we with the old legacy infrastructure versus what's the fintechs and the cutting edge doing? And typically the manual processes are there. We've talked about those. This is definitely a legacy way of working. We want to try and automate everything as possible, try and get rid of those approval workflows, or at least automate them. But better than that, put some guardrails in place and allow people to work within those guardrails. Centralize the system. So this is typically what we see with banking organizations. They've got pretty monolithic cores. This goes back to the old mainframe days of how regulation forced certain infrastructure to be used. And now there are different ways to attack that, but having things in a central monolithic block makes it very difficult to scale. It's difficult to add modules onto a big monolithic block. We've had organizations who will dump the database out because they can't run the analytics on the database within the infrastructure it's on, so they'll dump it in something more modern. It's not an elegant solution, but it's a workaround. And then we have the high operating costs, and there is significant expense when you are dealing with very large monolithic lumps of hardware in particular, but also in software as well. So the way that the fintechs are working now is very different. Everything is digitalized. Everything has a digital approach to it. So let's think about how automation can be applied everywhere, right through the whole process. Think about how the architecture might be organized. Certainly, microservices is the preferred way to go, but you do have to be careful. To go too small, make them too micro, you're going to add additional and unneeded complexity. So it's great to break it up into chunks, but just be careful of the size of the chunks. And then loosely couple those with things, like very open APIs. That gives you the ability to scale in an agile way, quickly respond to market needs. If there's a new trend, you can bring a new service online very quickly and adapt to those processes in a fast way. And this really underlies the way that platform engineering teams are now set up to be able to respond in a fast and agile way to a new service request, for instance. What's the next one? So can you run the? This is. I'm just going to quickly introduce some of the concepts of cycloid. This is a very, very quick overview of cycloid. Hopefully it will run. Yeah. So
bingo.
This is by no means a full demo, but certainly it just shows a little bit of what cycloid looks like in the real world. We can obviously organise a full demo if this is something that you're interested in. So we break it down into 3 users. There's the end users, there's the DevOps teams that maintain some of the catalogs, and then there's the platform teams that are maintaining access and the actual platform itself. So this is what it looks like when you create a project. That's the catalog. We're doing just simply creating an AWS instance here, very straightforward automation. The automation is the same depending on which environment you want to create. So it's a reusable automation. This form allows you to tailor the experience that the users have. So underlying automation is the same, but the experience can be very different, and you decide what the form looks like. This shows some of the FinOps tools we've got, being able to look at all your clouds in one place and not just look at your cost and where they're being used, but also look at the energy consumption and look at your carbon emissions. Sustainability is something that's so important now. Being able to look at that makes a big difference. Here we're creating stacks where we create the automation using templates, or we can even take infrastructure you've manually deployed and create infrastructure as code from that. So suck it back in, create infrastructure code. Everything is stored in your Git. This is just showing that. We're completely GitOps based, and that's GitOps not just around your automation, but also around your configuration. And this is just showing how easy it is to set up the forms for your end users. It's just a simple YAML file, and you can create really nice flexible forms. Now, underpinning it all is the role-based access control. Cycloid is fully multi-tenant. You have the ability to create roles. The experience that your users will have will depend very much on the role that they're in and the organisation that they're applied to. So as it's multi-tenant, you can have different catalogues for different organisations. People can be members of multiple organisations. It's very easy to set up and decide, you know, who has what access and what roles they are and which organisations they're in. So we do typically everything's underlined by Terraform. So that was really quick. I know we're trying to cram a lot in a few minutes. So very quick demonstration. If you want something more detailed, we're happy to do that. If you can just close that and just quickly move on. Thanks. So this is typically how we would move towards a platform engineering approach. We start with automating everything and underpinning that with governance. We strive for everything as code, and that's not just infrastructure as code, but also configuration as code. And what I mean by that is your day-to-day operations, the way you've configured your environments, they're also stored in your Git, so you can version control them in exactly the way you would a code base. Which is a really flexible way to deal with day-to-day operations. Everything's done via the self-service portal. You can start small, and we certainly recommend that. Just with a small business unit, start with some small virtual machines or a cloud. Build your model out. Involve your end users. There is this concept in platform engineering is that your end users being your customers and you providing a service. So you would set it up in the same way you would run your business. Listen to your customers and evolve your services to meet their needs. Once you've got that, then scale it out. Next slide, please. So these are some of the direct benefits. Certainly, platform engineering can integrate some legacy systems, and it allows you a path to move to some modern ways of working. It also allows you to move to more regularly compliance processes because you're going to template everything, things are reusable, makes that a much easier journey. The day-to operations, we discussed having a GitOps approach to your configuration, it just makes day-to operations much easier. And then lastly, we believe that the sustainability, the cloud footprint, all that lives within the platform engineering team. That's where it should be. That's where the biggest benefit is of having that, rather than perhaps having it in a finance team or a cloud management team. Putting it in platform engineering, you can really impact before things are deployed and while things are being deployed. The next slide. I'll just quickly run through this. There are challenges. A lot of them are challenges with implementing any change. I'll probably just talk about cultural resistance, because this is probably one of the biggest difficulties we come across. It is difficult to make any change, and platform engineering is quite a structural change. So that's why we sort of say start small, bring your champions with you, and move it on, in a step-by-step basis. And obviously, any change comes security concerns. So be aware of that. Go into it with your eyes open. I just particularly mentioned the skills gap because it is probably one of the most important things. Is bringing the skills into build platform engineering team is quite difficult. It's difficult to find these people. So one of the ways to address this is to upskill your existing team, and part of our platform allows for different types of skills of users, so you can bring people in and build them up through the skills path. Finally, my last slide. So this is what it looks like. This is how Gartner look at platform engineering. Gartner have said in 2026, 80% of all organizations, all large organizations, will have a platform engineering function. So this is how the structure looks. We have underlying infrastructure. We have infrastructure platforms that deal with things like infrastructure as code. Then we have the platform team themselves. In there, the reusable automation, the tools, and we're going to come on to some of the tools in a minute with the feature flag tooling. That's where it fits within the platform engineering. Obviously, the sharing of knowledge. Then we have the developer portals, which are obviously servicing the DevOps team, but also we have the as a service. So these are the other services which may not be directly out to through developers, but directly out to users. and ultimately, it's the projects and services. So that's it. So over to you, Matt.
Cool. Thanks, Rob. And we'll come back to Q&A and stuff at the end too, so we can come to like any questions that are coming up about platform engineering, feature flags, or the two together. So yeah, thanks, Rob. Matt, you're up.
Great. All right. Yeah, just start us off with the the easy question: what are feature flags? So there's a link here to an article posted by Flickr back in 2009, which, as far as we're aware, is pretty much the first written literature on feature flagging. So I would recommend, if you have the time, to go and read that. But at its core, feature flagging is kind of external if statements, if you like, right? So in your code, you can write an if statement, but that if statement can be defined by some third-party service which allows you to control that, right? So you can wrap parts of your code in a feature flag that allow you to turn them on and off remotely. There's a lot more to it. You can use feature flags for remote configuration. You can do A/B testing. You can do other things, but at their core, really, they were designed to allow you to turn things on and off through a separate service, which allows you then to deploy things independently of your release calendar, if you like. Cool. Next slide, please, Anna. So when should I use feature flags? So obviously there's a lot of reasons why you might want to use feature flags. The first one is the typical argument that we see, which is to decouple your deployment and your releases. So a lot of the businesses that we work with have these kind of large scale deployments that come around every month or every 3 months even, where there's a big load of code that needs to get deployed into a particular environment. And that creates a lot of anxiety. So what we can do is we can decouple the deployment from the release by pushing the code out behind feature flags and then use the feature flags to control our releases instead. And that's kind of the same thing as point 2 here, which is around tighter pull request loops. If you're pushing code out quicker, you're writing smaller pull requests because you can wrap things in your feature flags. You can also use feature flags to segment and target your users. So that might be to create beta tester groups, or it might even be to create different groups of your end users, right? So you might be able to use tiers for your customers through feature flagging, and we have customers that are using the feature flagging software to achieve things like that. Next one, and another really typical use case, is around phased rollouts and canary releases. So being able to roll your features out slowly to smaller groups of customers, so that you can monitor the metrics and verify that feature is effective and not defective, if you like. So the next one, A/B testing and multivariate testing. I did talk about this a minute ago. You can use feature flags to do more analytical type tests by giving different users different features and monitoring more. That's more around monitoring the effectiveness of a particular feature. And then finally, increasing cross-team velocity. So obviously, in larger teams, you will have multiple larger organizations. You have multiple teams working on different components, and that often creates cross-team dependencies, which can put a strain on your releases. So feature flagging can help you remove those dependencies by allowing different teams to deploy their code into their microservice, or if you're talking slightly smaller, it might just be a front-end team and a back-end team, then you can use feature flags to control the release of different elements of those applications to allow you to increase cross-team velocity. Next slide, please. So I want to talk a little bit about one of our customers and a case study that we did with them. So we're talking here about KB Bank. They're a leading bank in the Czech Republic. So when we initially were talking to them, they had 400 to 600 developers managing a legacy system built on a monolithic architecture. And the critical thing here, I won't go through necessarily all of this, but the critical thing here is that they wanted to move faster, right? They wanted to be able to break that monolith down to be able to deploy things quicker, get things out quicker. So you can see here they had complex coordinated releases, and they were using a homegrown feature flag solution, but that adds an extra dependency, extra overheads within their teams to manage that, which they weren't really able to keep up with. So they were looking to outsource that to a feature flagging company, which we were able to help them with. So yeah, if we move on, great, thank you. So now that they've started using Flagsmith, I think they've been using it for maybe 3 or 4 years. They've obviously they have a massive monolith product that they were working with, but they've been able to move towards a microservice architecture, and feature flagging was critical in being able to do that. So they were previously, I think, only deploying about 3 times a year into their monolith. So now, by breaking that monolith up and using feature flags to do so, they're deploying a lot more often. We don't have the stats on how much they're deploying directly into production, but they're deploying daily into 2 non-production environments by using CI/CD, and feature flags will help them achieve that. And they're able to ship a lot faster because they can ship to their microservices much quicker, and they've saved money as well. There's less infrastructure maintenance costs. They've been able to remove their homegrown feature flagging platform, which obviously reduces the overheads there as well. Next slide, please, Anna. So obviously we've talked now about a lot of things about why we would use feature flags, but they're not necessarily a golden bullet. They're not going to solve absolutely everything. So there's a few points here as to why we would not necessarily recommend using feature flags in certain use cases. So if there's an unusual legacy stack, for example, that there's less and less of this these days, but certain stacks don't lend themselves to using feature flags, or even kind of offline platforms. It is harder to use feature flags in those kind of platforms. And the next one is not to overuse feature flags, right? They do add a certain level of overhead in terms of having to manage your feature flags so that they don't get unmanageable. So it's important to consider what should have a feature flag and what shouldn't, right? If you're adding, let's say you're changing the text size in a certain widget on your UI, you probably don't need to use a feature flag for something as minor as that. But if you're adding a new widget, then yes, go ahead and use that's kind of what we would advertise or advocate using a feature flag for. So it's just making sure that you're not creating additional complexities in your code by adding feature flags where they're not necessary. And that kind of leads on to the next one, which is around stale flags being an anti-pattern, right? There is a level of management that comes with feature flags, making sure that your code isn't littered with feature flags that have been enabled, but they're still in your code, right? The life cycle of a feature flag tends to be the developer creates the feature flag, they write their code, they wrap that code in the feature flag, they have their rollout process, whatever that might be, and then eventually they enable that feature for everyone. At that point, there should be a trigger for, okay, I need to remove that code that was wrapping my feature from the code base. So introducing those practices is very important when it comes to feature flagging. And then finally, just being aware of the potential for outages, right? So there may be some components in your application that are critical paths for certain user journeys, and introducing third parties into those sometimes is not a good idea, or may not even be possible due to some kind of restrictions internally in your organization. So that is a consideration that we often see, and sometimes flags aren't the right thing. That being said, there are a lot of things that you can do to mitigate that. There are kind of offline modes that you can implement in case the feature flagging service is not available. You can implement things that will handle those scenarios, but certainly it's a consideration that should be put in place, that if there's certain user journeys that are too critical to have any reliance on third parties, then maybe feature flagging isn't quite right. Okay, on to the next one, please, Anna. Cool. Yeah, so just a bit about getting started with feature flags. I've talked a little bit about this. So identifying your use cases. So we talked a lot about the use cases on one of the earlier slides, but each business has a different use case for feature flagging. I think every business would be able to find a use case for certainly the traditional application of feature flagging, which is being able to turn things on and off remotely, but then identifying the additional use cases that may be useful, like your phased rollouts and your canary releases, is something that is good to identify up front. As I mentioned a minute ago, starting small, start with some new features, or if you are breaking a monolith down, you can use feature flags to reroute traffic, right? So if you've got a monolith and a microservice that you're creating, you can start by using feature flags just to route the traffic between the two the two different parts of your application, right? So old traffic to the monolith, and any new traffic that comes in could go to the microservice. So next is considering how you want to manage your flags. So whether you want to go homegrown versus an off-the-shelf tool, such as Flagsmith. So we would and there's kind of a spectrum here, right? Like certain people would argue that just environment variables are a form of feature flagging, right? And I don't necessarily disagree with that, and that is a very rudimentary kind of feature flagging methodology, if you like. But yeah, the consideration then is whether you want to build something yourself. Maybe you have very bespoke requirements, or maybe you don't find anything off the shelf that really works, but you therefore need to be aware of that extra overhead, especially as teams grow. You get more requirements from different teams on how they want to implement feature flagging, and we often see eventually that people give up on their homegrown solutions and look for something off the shelf. And I will just call out here as well, the Open Feature Project is something that we're heavily involved in. It's a project that consists essentially of a set of SDKs that are vendor agnostic. So instead of choosing Flagsmith and using Flagsmith, Flagsmith SDKs directly. You would still use, let's say, Flagsmith or even a homegrown solution, but you would use the open feature SDKs to implement the flagging in your code. And what that allows you to do is in the future change your vendor, right? So what we're starting to see people do is who do have homegrown solutions is implement their own open feature providers, they're called in the open feature world. So they'll implement a provider for their homegrown solution, implement the open feature SDK, and then that will give them the flexibility in the future when they outgrow their homegrown tool to move to another third party or better tool. Yeah, and then number 4, considering feature flag life cycles and technical debt. I already talked a little bit about this. So just being aware of really making sure that you implement those development practices of clearing up any stale flags in your code. And finally, shifting the mindset around releases. So it's something that we see everyone struggle with, is kind of getting away from the anxiety around deploying code into a production environment, right? So what we're trying to achieve here is and this is kind of the kind of almost pie in the sky goal of everyone deploying code as soon as it's into production, as soon as the pull request workflow that you have is completed and the code has been merged, deploy that into production, and then worry about the release via your feature flags. It's never that simple, but obviously that's the goal that we're striving towards. So shifting that mindset at least more towards that of just, yeah, code's done, deploy, code's done, deploy, and then managing your releases through your feature flags. So shifting that mindset is something that is important here as well. Okay, on to the next slide. If there is one, I can't remember. Okay, there isn't.
Q&A. Cool. So we will, thanks, Matt. That was great. We will have some time now to answer any questions that anyone has, whether about feature flags, platform engineering, or anything that kind of bridges the gap between the two. So we have some already that have come in. One of them is that, I mean, both of you have spoken a bit to like the cultural blockers and people doing things the way that they always have, especially in banks with like the legacy systems. I'd just love to hear, yeah, but what are your thoughts on how that's changing?
Okay, I can start on this one. This is definitely one of the biggest challenges that all organisations face, but banking in particular, because there's a lot of the banks have been around for a long time, so they've been doing things in a certain way for a long time, and change is hard. Now, the approach we've taken is you've got to find a champion within the organisation. There's no point coming in with your new shiny ideas and trying to convince everybody this is the way to do it. You need champions. Work with those champions. They'll help you find the right people within the organisation, and then start small, and you have to show value. So once an organisation sees there is some value in what you're talking about, and it can be demonstrated, then you'll start to get some traction, and hopefully you'll get up through the management chain. And one of the challenges we have with platform engineering is it does touch quite a lot of different departments. So quite often you need multiple champions in different areas to really get that ball rolling and get the snowball effect. But yeah, that's my advice: is try and find a champion and work with your vendors in a collaborative way to roll out.
Yeah, definitely agree with that. The successful businesses that we see are where we've got a really enthusiastic champion for feature flagging, and it's something that we can help with as well by training, helping to train the champion to then train internally within the business and encourage people to use modern practices where they can. Yeah.
And do both of you see those cultural blockers? Like, are they moving? Do you see there being some progress in like the cultural mindset changes?
I might be blunt and say no. I've been in the industry for a while, and change is still as hard today as I think it ever has been. Certainly, I think the benefits once you get the ball rolling, certainly I think things can move quickly. But getting that initial movement of an organisation that's been doing things for the same way for a long time, it's hard. And I think we're humans, that we don't like change. That's the problem.
Yeah. What about you, Matt? I know that feature flags are changing, like as a space, but do you think there are still the same like cultural blockers to people bringing them
in? Yeah, it's interesting. I think it really does. It does vary. I think there is a slight change. I think I agree with Rob that certainly in the larger organizations, it's much harder to change people's mindset. But we're seeing a lot more in the kind of mid-size enterprises that people who have moved from smaller organizations where these kind of modern development practices are in place are able to kind of infiltrate, if you like, and try and make changes. So certainly when we see that, it's really interesting to see. Like we're working with a large car manufacturer at the moment in the US, and their platform engineering team is one of the most modern and forward-thinking teams that I've had the pleasure of working with. So we do see it in certain organizations, and when we see it, it's you can really see the benefits. Yeah.
That makes sense. All right, Rob, this one's for you. You said 80% of large organizations are predicted to adopt platform engineering by 2026. Where do you think banking is today with platform engineering maturity?
Yeah, that's a very interesting one. Yeah, that's a Gartner prediction, and I think a lot of it depends on how you think about this in terms of the maturity cycle. I would say most banking organisations I speak to are already on the route to platform engineering. Most of the whole cloud adoption thing is happening or has already happened. They're adopting GitOps processes, modern development practices. All this is happening in every bank I speak to. But then there's, as Matt was saying, there are organisations you meet who are they've just got it. They're in top gear and they are motoring ahead to get platform engineering established as quickly as they possibly can. They're eager to learn. The people I love talking to, people always ask me, what do you see in the industry? What are other people doing? Where do you think we are? They're looking to benchmark themselves. They already want to be really ahead of the game. So I would say most organizations are moving, but to get to that, where I think Gartner are saying 80%, I think they're saying, fully adopted, fully mature, the way they're describing it, I think there's quite a way to go. There's quite a way to go. And certainly we are a couple of years off. I think they're right there, maybe even a little bit more, because I see platform engineering also developing as a discipline as well. So it's not a kind of, here's the goal, you're there. It's going to be, okay, we've got everything we need, but we also probably want to be thinking about what's coming along in the future. So a bit of a moving goalpost to say it, where everybody is. But that's my experience. And my experience is, yes, majority of banks are already moving in this direction, if not a long way down the route.
Okay. Interesting. Makes sense. Matt, this one's for you. When can feature flags become a liability? What are some of the pitfalls you see?
Yeah, it's it kind of goes back to what we were saying about when not to use feature flags, but I think the important thing is maintaining the enthusiasm for feature flagging and implementing the practices. So when feature flags become stale is when they become a liability, right? Or when you don't implement the right practices for using feature flags, and even the workflows that you use within that feature flagging tool, right? So making sure that you've got the right processes in place, the right restrictions in place to make sure the right people can change the flags in your production environment, for example, or implementing like 4eyes kind of change request workflows to make sure that things that are changing in production are right. So yeah, I think we do see certain cases of customers turning on flags incorrectly, or suggesting that they might have been turned on incorrectly, and it's usually because they haven't got the right processes in place to make sure that someone else is looking at the feature flag change before it goes into production, and making sure that the right roles are set up in place to do that.
Okay, that makes sense. We're going to probably have time for like one or two more before we start to wrap up. So if anyone has any more questions, feel free to just send them in. Otherwise, Matt, you're still in the hot seat because there's one more for you. Right. Is there an easy way to clean up feature flags and to help protect against stale and technical debt?
Yeah. Short answer is no, right? There's no easy way to do it. It is a challenge in the industry that we as vendors are working to try and simplify by providing the right level of metrics to show when things do become stale, but actually removing them when they become stale is still a process that for the foreseeable future has to be a manual edit of some code, right? Like a feature flag is in its purest form is a few lines of code wrapping some other code. So that code needs to be removed once it becomes stale. So we as vendors give our customers the tools to be able to identify when things do become stale, but actually cleaning them up is still the most important thing, is making sure that you have those practices in place. It's understood that developers need time to focus on technical debt, just like other bits of technical debt, right? It's not just feature flagging. Every organization has technical debt, and making sure that is adequately prioritized, and that feature flags are understood to be part of that once they've served their purpose, if you like, is really important.
Okay, thanks, Matt. All right, last one. Rob, this one's for you. You mentioned everything as code as a step to kickstarting platform engineering. Does it have to be like that?
No, but that's definitely the preferred way. It's the most efficient way. The automation pretty much revolves around codifying activities. So if you don't have the activity codified, then it's very difficult to automate it. So infrastructure as code just brings so many more benefits, and just opens so many opportunities to create automation which just aren't there if you don't have that in place. If we think about configuration as code, yes, you can manually manage your configuration, but once you bring it and you have configuration as code and you've got it into your Git and you're starting to treat it in the same way as you would your development code or your application code, then you get the benefits of dealing with dealing with a GitOps approach. You now have those. You can look at the history. You can do things like rollbacks. things that which are very difficult to do with configuration, such as sharing responsibilities, something we do all the time when we build code. We have pull requests, we service those pull requests, we put it back into the branches. We have a way to collaborate on code, which is very well defined and very well understood and very efficient. Once you do put configuration as code, you can apply all those techniques to your configuration, which are incredibly difficult to do when you don't have it. You don't have it as a code, and you're taking each individual change as a manual step. So the answer is yes, you could do some of the pieces without making them as code, but you won't get the benefits. Really, you need to go into it with the mindset of this is how we're gonna deal with all the features and functionalities. We're going to deal with them as a code basis. Then you really see the benefits. Then I think you get the biggest advantage by a long way. So hopefully that answers it.
I think it does. That makes sense. Cool. So let's start to wrap up here then. For everyone here, the recording will be sent to you afterwards. We can also send all of these links, so everything will be available. Get in touch if you do have any questions, or if there's anything you want to talk about, either with Rob, Matt, or anything different. But yeah, thanks Rob for joining, thanks Matt for joining, and thanks everyone who's been here as well. And it's been really interesting to talk a bit about the before and after and what's happening in the space.